Hi everyone. Today we're talking about something called power functions. Power functions are the last new thing we need to learn about in this chapter. You'll see that technically this was supposed to be the first thing we learned about in this chapter, but this doesn't really fit or follow from any other lesson in this chapter, so it kind of stands out there on its own, and I figured the end of the chapter was a good place to hit it. So some of this stuff is going to sound familiar to you, because you've already learned it. We've already talked about it, okay? But this is the last little bit that we have to get in before your test. So this part we already wrote down on your flip book, I believe, when we made it at the beginning of the chapter. But it would be a good idea to write it down here too, because it is on your assignment for tonight. So when I write an expression like this, something to the power of something, that entire expression is called a power. Okay, and I know you're used to thinking of just the number up here as the power because we read this as x to the power of n. But technically when I say a power, I'm talking about this whole expression. Okay, some other terminology you're going to want is the x is called the base and the n is called the exponent. Okay, and again, I expect that you already know those words, but there are some questions on your assignment that have to do with the base and the exponent and the power. Okay, and so today, like I said, we're talking about something called power functions. And remember, functions are like relationships between numbers that you can graph and analyze and things like that. So this down here is what I would call a function. Okay, so if I write an equation that's like something equals x to the power of something else, and usually this would be a number. Okay, so like y equals x to the third power, y equals x to the fourth power. That's what's called a power function. Okay. So we separate power functions into even and odd categories. Okay, so an even power function would be one where the exponent is even. So x squared, x to the fourth, x to the sixth, something like that. Okay? And all even power functions share some common characteristics. The graph of an even power function is U-shaped, kind of like a parabola. Okay, it's going to look like this. And you'll notice that a parabola, remember, came from a graph of y equals x squared. So now we're just expanding that to include x to the fourth, x to the sixth, x to the eighth, and so on. So that U shape, technically I believe it's only called a parabola when it's x squared, but they all have that same sort of characteristic shape. The domain of a graph like this is all real numbers. Because you can plug anything in for x that you want to. You can plug in positives, you can plug in negatives, you can plug in whatever you want. And also if you think about it on a graph, and it looks like this. If you draw those imaginary lines out to the right and the left, and you extended those blue lines forever and ever and ever, you would always hit everything from the left to the right. So that's when we would say our domain is all real numbers. That's going way back to chapter 1 when we talked about domain and range. So speaking of the range is all positive real numbers, because you'll see that this graph never dips down here. Okay, it never goes down to where y is negative, which would be down here. All of these graphs are centered right at 0, 0, and then they go upwards. So domain is all reals, but the range is positive reals, no negatives. Okay, and also good to know that these graphs have a line of symmetry, which happens to be the y-axis. So see this line right down the middle? That's a line of symmetry for my graph. Okay, so no matter which one of these you graph, they're all going to have these 4 characteristics. Let's talk about odd power functions. And of course, odd power functions would be like if you graphed x to the y equals x to the third, or x to the fifth, or x to the 27th. Okay, anything odd. And the graph of these is squiggle shaped, and I wish I had a more official word for that, but I really don't. That's actually a really bad drawing of that. Hold on. Okay, the graph looks something like this. It's not so much better, but and what it really is, I want you to compare this. Oh, let's see. I'll give myself some space here. I want you to compare this to the graph that we just looked at, like the parabola type graph. So the parabola type graph looked like this, and the squiggle shaped graph looks like this. And so what really the difference is this piece right here. Okay, if I took this piece of a parabola and flipped it downward, so if I took it and put it down this way, if I flipped it down, it would look like this. So it's really a matter of taking this end of the graph and either pointing it upward or pointing it downward. And that has a lot to do with what we've talked about with even and odd numbers with powers. Because think about what happens when your x's are negative, when you're raising a negative number to a power. If it's an even power, remember we said all those negatives are going to cancel out, and so it comes out being positive, and that's what this is showing, is that when I do a negative number, because all these x's are negative, and raise it to an even power, my answer comes out positive. So see how it heads upward? My answer comes out positive. Over here, when I choose a negative number and raise it to an odd power, so if you did -4 times -4 times -4, so 3 -4s, it's going to come out negative, and that's why this points downward. Okay. Domain is still all real numbers. Okay. So just like before, so really both of these, the domain is all real numbers. On this one, the range is also all real numbers, because you'll see that this graph points upward and downward. So if I drew an imaginary line up, my graph's eventually going to hit it, and if I drew an imaginary line down here, my graph is eventually going to hit it. And this one doesn't have a line of symmetry, but it has what's called rotation symmetry, which means if I put my finger right there on the center of the graph and spin it, it will land back on itself before making it a full 360 degrees. Okay, so this one doesn't have a line of symmetry like the parabola does, but it has what's called rotational symmetry. Okay, so here's an example of a problem that would use a power function. Louisa is taking a quiz. Unfortunately, she didn't study or pay attention in class, so she is going to simply guess, like randomly, eeny, meeny, miny, mo, guess. Okay? And we're just going to say the probability of her getting any one question right is P. And I want to write a function to show the probability that she'll score 100%. Okay, well, I've got 5 questions on this quiz. Here are my 5 questions. And the probability of getting each one right is P. Okay, so I'm going to fill in each box with a P. Okay, and now I want to take those and multiply them together, because that's how I would find the probability of getting this question right and this question right and this question right. I want to get 100%, so I want to get all 5 of them right, and that's when I would have to multiply them together. Well, look at what you've got here. P times P times P times P times P. Easier way to write that would be P to the 5th power. And so if I wanted to write a function for this, I would write like y equals P to the 5th power, and then I could plug in different values for P, meaning different probabilities on the different questions. So a multiple choice question with 4 answers would have a different probability than a true or false question, for example. Okay, so working with that same idea, and this goes right back to what I was just saying. Let's suppose this was a true or false quiz. Okay, so the 5 questions were all true or false. If it's a true or false question, think about the probability of getting a question right if you're randomly guessing. In this case, my probability would be 1 out of 2, because I have 2 choices and one of them is the right one, which is equal to 0.5. So if I wanted to get 100% on this 5-question quiz, I would do 0.05 to the power of 5, and that would give me my probability. And I believe I get 0.03125. Okay. So that's roughly a 3% chance of getting 100% on this quiz if I'm randomly guessing. Okay? So let's bring up our next scenario here. If this were a multiple choice quiz with 5 choices for each question, what's the probability of getting 100%? So if a question is multiple choice, and it's got 5 choices, you've got a 1 out of 5 chance of getting the question right, which is equal to 0.2. So if I have 5 questions, my overall probability would be 0.2 to the power of 5, which is equal to about 0.00032. And I think that, oh, no, that's probably right. I was going to say that probably rounded off. But so that is like a less than 1% for sure. It's like 1/3 of a percent of getting 100% there. Okay, so another type of problem that you'll see quite often is something like this, where I give you a coordinate and I say the point -2, 64 is on the graph of a power function. And I want to know, is this function even or odd? And you can tell just by looking at it. And here's what I want you to focus on. This was a negative number, and I had to raise it to some power to get it to turn into 64. So I did -2 to some power, and it became 64. But look at what happened. I had a negative number here, and when I raised it to a power, it became positive. So think about which type of power function has that happen. That's what happens in even power functions. Okay? I would say this is an even power function because the negative turned positive over here. Okay? Then it says, does the graph have a minimum or a maximum value? If so, what is it? Well, if it's an even power function, it's a parabola, right? And so it would have a minimum right here at the axis, so the minimum value would be 0. This is going to come up looking a lot nicer in just a second. But this graph would have a minimum point. If it were an odd power function, it wouldn't have a minimum or a maximum. You're going to see that in a minute. Okay, so my minimum point is at 0. And then this question is a really easy question that people tend to mess up a lot. Write an equation for the function. Okay, as soon as I know that it is a power function, I know that my equation should look like this. So you can see it. It should look like y equals x to some power. So the only thing I have to figure out is what power this is. Okay? And the example that I'm using is -2, 64. So what I'm really trying to find is -2 to what power would equal 64. Okay? And furthermore, I know that that power must be even. Okay? Because we figured out above that this was an even power function. So at this point, the best way to go is just guess and check. Now, remember, this is a negative number, so when you're going to raise it to a power in your calculator, you've got to wrap it in parentheses. But I just want to start taking -2 and raising it to some even powers and see which one comes out to be 64. So I would do -2 to the power of 2, -2 to the power of 4, -2 to the power of 6, -2 to the power of 8, until I find one that comes out to equal 64. Let's see, I do believe it's going to be the -2 to the power of 6. Okay, so you're just guessing and checking, but making sure that when you're typing them in your calculator, you are putting that -2 in parentheses, and you're looking for one that comes out to be 64. So since I found that it's this one, my equation would now just say y equals x to the 6th power. This is what I would want to write down as my answer. Okay, because I'm writing this is one point on a graph, but there are lots of other points too. So this is the equation that would represent all of those points. Y equals x to the 6th power. All right, let's try that again. This time I've got the point 4, -1024. And I know it's on a power function. Okay, so again, is this even or odd? I want I want you to look what happened with this negative number. I gave you an x that was negative, and the y still came out negative. That means we took -4 and raised it to some power, and it was still negative when we were done. That means it must be an odd power function, because odd power functions are the ones that keep your number negative. Okay, remember, evens cancel out negatives. Okay, this particular graph is going to have this kind of shape. Just sketch it real quick. So it keeps going up forever and down forever. So it doesn't have a minimum or a maximum because it keeps going up and it keeps going down. So I would say no, it doesn't have either one because the graph extends forever in both directions. And then once again, write an equation for the function. Oops. Our equation is going to look something like this. Y equals x to some power. So remember, our only focus is on figuring out what power that is. And I know then that I'm looking for -4 to some mystery power that would come out to equal -1024. And because I figured out that this is an odd power function, I know that the power I'm looking for must be odd. So I would start with, well, you probably don't have to do -4 to the first power. Okay, you should know that that's not going to be it. So maybe -4 to the third, -4, to the fifth, -4 to the seventh, until you find one that works. Okay, and by works, I mean find me one of these powers that turns the -4 into a -1024. I believe, again, it comes out to be this one. So then the graph of my, the equation I would write, oh man, I am messing up all over the place. The equation I would write is y equals x to the 5th power, because we found that it was the power of 5 that connected this number to this number. Okay, so you've got a couple of those on your homework tonight, and this will show up again on your test. Okay.